What if I told you that everything you've ever seen is just a tiny fraction of what's really out there? Look up at the night sky. You see stars, maybe a planet, or the faint glow of our own Milky Way galaxy. You might think that's the universe. But all of it, every star, every galaxy, every black hole, every speck of dust and every living thing makes up less than 5% of the cosmos. The rest, a staggering 95%, is completely invisible to our eyes and our instruments. It's a cosmic ghost, a presence we can feel but cannot see, shaping the universe in profound and mysterious ways. This isn't a wild guess or a science fiction story. It's one of the most profound discoveries in the history of science. Think of a spinning merry-go-round. The kids on the outer edge have to hold on tight, or they'll fly off. Galaxies are like giant cosmic merry-go-rounds made of stars. When astronomers measured how fast stars on the outer edges were spinning, they found something shocking. They were moving way too fast. Based on the gravity of all the visible stars and gas, those outer stars should have been flung off into space billions of years ago. But they weren't. Something was holding them in place. That something is what we call dark matter. It's the invisible glue of the cosmos. Scientists calculate that for every 1 part of visible matter in a galaxy, there are about 5 parts of dark matter. It doesn't shine, it doesn't reflect light, and it doesn't emit any radiation we can detect. It seems to pass right through normal matter as if it weren't there at all. Yet, it has gravity. A lot of it. Without it, galaxies as we know them simply wouldn't exist. For most of the 20th century, astronomers debated the ultimate fate of the universe. Would gravity eventually win, pulling everything back together in a big crunch? Or would the expansion that started with the Big Bang slowly coast to a halt? In the late 1990s, 2 teams of scientists set out to answer this question using distant, exploding stars as cosmic lighthouses. What they found turned cosmology on its head. The expansion of the universe isn't slowing down, it's speeding up. Imagine throwing a ball into the air and watching it accelerate upward faster and faster instead of falling back to Earth. That's what our universe is doing. Something is counteracting gravity on the largest scales, pushing galaxies away from each other at an ever-increasing rate. This mysterious force was given the name dark energy. It is the single most dominant component of the cosmos, making up nearly 70% of the total energy and matter content of the universe. As the universe expands, more space is created, and with it, more dark energy. It's a force that grows stronger as the universe gets bigger. So, how do we find something that is, by its very nature, invisible? We get creative. For dark matter, scientists are fighting a war on 3 fronts. Deep underground, experiments like Lux Zeppelin use giant vats of supercooled liquid xenon, hoping that a dark matter particle will bump into a xenon nucleus, creating a tiny flash of light. The second front is in space. Instruments like the alpha magnetic spectrometer search for dark matter's fingerprints, gamma rays or antimatter produced when dark matter particles collide. The third front is at particle accelerators like the Large Hadron Collider, where physicists try to create dark matter particles by smashing protons together at nearly the speed of light. For dark energy, upcoming observatories like the Vera C. Rubin Observatory will create the largest, deepest movie of the universe ever made. By mapping billions of galaxies over a decade, it will give us an unprecedented picture of how cosmic expansion has changed over time. Every time we have peeled back a layer of reality, from discovering that Earth is not the center of the universe to realizing that atoms are mostly empty space, our perspective has shifted profoundly. Uncovering the nature of this 95% could lead to new understanding of gravity, new dimensions of space, and a completely new picture of physics. The universe is whispering its secrets, and we are, for the first time in human history, learning how to listen.